Friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Now we will do problems on students' recommendation. This is a problem on fluid dynamics which is asked by Strum, a spiritual beast. He's asking the question on XEB 2015 question 22. Let us solve this problem. The question goes like this. A plain jet of water with volumetric flow rate of 0.012 meter cube per second and cross-sectional area 6 into 10 power minus 4 meters square strikes a stationary plate inclined at an angle theta and leaves as two streams as shown in the figure. The ratio of the discharge through section 2 to that of the section 3 is 3:1. The velocities may be considered uniform across the cross-section and the effects of friction may be neglected. The density of water is 1000 kg per meter cube, ignoring the effects of gravity. The magnitude of the normal force exerted on the plate in Newton is dash. So let us solve this problem. Now, one of the important thing we have to see is force is rate of change of momentum. That is, I can say on the fluid, if it is there, it is P2 dot minus P1 dot. This is on fluid. If I say on vane, it would be P1 dot minus P2 dot on vane. Okay, so let us see. Now first of all, let us take our force on the first case. Here one of the things we have to see is how do we calculate this theta. Here two things are not known. One is this theta is not known. Another one, force, the normal force has to be calculated. This Fn has to be calculated. How to do that? For that, first we have to find this theta. How do we find this theta? This theta can be found out by setting tangential force is equal to 0. The force in the tangential direction. Why the force in the tangential direction is 0? Because there is no frictional effect. Tangential force has to be there only because of friction. So here we are taking tangential forces as 0. So let us see how the things can be done. Now we will take this as P2 minus P1, okay, is equal to 0, or P2 dot minus P1 dot. What is P2? P2 can be written as equal to, I can say this 2, which is, I can say M2 dot into velocity. Here one of the main thing which has been told is the velocities may be considered uniform across the cross sections. It means that the velocity is same everywhere. Okay, so I am taking that velocity v. Okay, so P2 consists of M2v, which is coming in this direction. Okay, minus on this direction has to be negated. That is M3 dot into v. Then minus P1. This is P2. What is P1? P1 is what is coming in. That can be written as, we can say M1 dot into velocity into cos theta, because this is cos theta. This is theta, so cos theta. So now this can be written as equal to, now if I consider the portion of this, which is 4, is getting shifted into 3 into 1. So the portion, what is coming here, I will take it as alpha, and what is coming down here, I will take it as 1 minus alpha. So if I take M2 as a portion of M1 dot, that would be 3 by 4. So this would be 3 by 4 M1 dot into V minus 1 by 4, because the other one would be here. Okay, 1 by 4 M3 M1 dot into V, okay, minus M1 dot into V cos theta is equal to 0. Now if you see, M1 dot V cancels everywhere. What remains is here 3 by 4 minus 1 by 4 is 1 by 2 minus cos theta is equal to 0. So this implies my cos theta is equal to 0.5. So cos theta is equal to 0.5 means theta is equal to 60 degree. So this theta is equal to 60 degree. We have got that. Next one is normal force we have to get. That is the main question, normal force. Now Fn can be actually equal to, what are the forces? On the tangential direction, we will take now what? V2 minus V1. So we are taking P2 minus P1, that is on the fluid we are taking. Now P2 if you take, M2 dot V here, okay, what is going out is 0 because the angle is 90 degree. If you see this angle on the normal side, the angle is 90 degree. So cos 90 is 0. So it will be M2 dot into V, okay, cos 90 is 0. So that goes off. Similar way, M3 dot into V cos 90, that goes to 0. Minus only this one comes into picture, and this has to be shifted by 30 degree, because if this is 60 degree, this is 90, this is 30. So this would be M1 dot into V, M1 dot into V into cos 30. So let us do that. So this goes to 0. So normal force Fn is equal to, now if I consider this is on the fluid, this is M dot V cos 30 on wing. Okay. So now what is M dot V? Now M dot, if you take, it is rho into Q. What is velocity? Velocity can be written as Q by A. See, always it is better we write everything in terms of what is given. What is given is Q is given and the area is given. So we will write everything, and at the end we will do the substitution. Okay. This would be rho Q square by area into cos 30. Now if you substitute this, this would be 1000 into 0.012 square divided by area, which is 6 into 10 power minus 4, and that multiplied by cos 30. And the answer we are getting is 207.8 Newton. So what is the answer? It is 207.8 Newton. That is the answer. So this is what is given as the answer keys also. So I hope you have understood this, students. Any doubts you have, you please mention it in the comments and I will be answering that. Thank you very much, students.